When we hear the terms pair or a dozen in our everyday lives, we are sure that each of it is actually referring to a particular quantity or a number. A pair is always referring to the number 2. So we say, I've bought a pair of shoes. Similarly, the term dozen refers to the number 12. We can say a dozen eggs or a dozen bananas, which in either case are telling us that we have 12 eggs or 12 bananas. Similarly, we also have another term which is called a mole, MOLE, in chemistry. This is also referring to a particular number which is extremely huge. So it is 6.022 into 10 to the power 23. This is useful to express a very large number and is usually applied to atoms, molecules, or other particles. Say a mole of atoms means there are 6.022 into 10 to the power 23 atoms. Or when we say 1 mole of a molecule, we are actually referring to 6.022 into 10 to the power 23 molecules. Let's look at some quick examples. So we know hydrogen. Hydrogen is designated by the symbol H. So when we say we have a mole of hydrogen atoms, it means there are 6.022 atoms of hydrogen. Similarly, we can have 1 mole of carbon atoms. They'll also have 6.022 atoms of carbon. And this is how we name it. So when we say we have 2 moles of carbon atoms, it means there are 2 into 6.022 atoms of carbon. Okay, so I hope you got the concept here. So 1 mole refers to this number, which is also called as the Avogadro's number. Avogadro's number, which is designated Na. Okay, so this is for individual atoms. Now let's take the case of a molecule. For example, 1 mole of ammonia. Now ammonia is a gas, it's a molecule. So 1 mole of ammonia molecule will have 6.022 into 10 to the power 23, which is nothing but the Avogadro number molecules of ammonia. Okay, so the number is applicable to atoms as well as molecules or other particles also. So moles are extremely useful in chemistry to represent a large quantity of atoms or molecules. Now if we say 3 moles of ammonia, then it will be 3 into Avogadro number. Now the moles are actually related to grams. Moles are related to grams. If you look at the element carbon in the periodic table, it would usually look like this. So this is the name of the element, which is carbon. 6 is the atomic number and 12 is the mass number. Okay, so the atomic number will give us the total number of protons present in the nucleus, while the mass number is usually a combination of both the protons and the neutrons. This number 12 is actually called the atomic mass units or AMU. Okay, the number 12 is called the atomic mass units or an AMU of 12, which is usually referred to as the mass number. Okay, now this can also be written as 12 grams per mole. Okay, 12 grams per mole. It means that 1 mole of carbon weighs 12 grams and contains the Avogadro number of carbon atoms. Okay, so this number on top is actually called the AMU or atomic mass units, which for carbon is usually designated as 12 grams per mole. Now what this signifies is 1 mole of carbon weighs a total of 12 grams and would contain the Avogadro number of atoms. Avogadro number of atoms. Okay, so 12 grams will contain Avogadro number of atoms. Half of it would contain half of the Avogadro number. It will have half of the Avogadro number. Similarly, if you were to take 2 moles of carbon, then it would weigh 24 grams because 2 into 12 will give you 24, and this would contain 2 into Avogadro number. We can also take 10 moles of carbon, which would be 10 into 12, that is 120 grams. Okay, so 10 moles of carbon would weigh 120 grams and would contain into Avogadro number of carbon atoms. Okay, so by this we can say that 12 grams per mole is the molar mass of carbon. It's the molar mass of carbon. Let's take the example of oxygen, which is designated O. Now oxygen is usually designated like this. So it has an atomic number of 8 and a mass number of 16. So the molar mass of oxygen is 16 grams per mole. So if you weigh 16 grams of oxygen, then that would contain Avogadro number of oxygen atoms. So the Avogadro number is 6.022 into 10 to the power 23. So this is in 1 mole. So 1 mole of oxygen would weigh 16 grams and would contain this many number of oxygen atoms. Similarly, if you were to take 4 moles of oxygen, then that would contain 4 into Avogadro number of oxygen atoms. Okay, so the number of moles equals 4 into Avogadro number of oxygen atoms. So this is for atoms. Now let's take an example of a molecule which is carbon dioxide. So we know that 1 atom of carbon weighs 12 grams. So the molar mass of carbon is 12 grams per mole. Similarly, oxygen's molar mass is 16 grams. Now, carbon dioxide has 2 atoms of oxygen, so it would be 16 into 2, which is 32. So if we add both carbon and oxygen, we would get 44 grams. This is the molar mass of carbon dioxide. This is the molar mass. So if you were to weigh 44 grams of carbon dioxide on a weighing scale, then that would have Avogadro number of carbon dioxide molecules, because 44 grams is the molar mass of carbon dioxide.